Hi, let's look at these simultaneous equations and how we can solve them by using the elimination method. Alright, so in the elimination method that we are going to uh, learn in this video, what we aim to do is to eliminate or get rid of one of the variables here. So we have two variables, a and b, and we have two equations. Alright, so always remember when you have a single unknown, single variable, a single equation is enough to solve it. But when you have two unknowns, you need two equations to solve them. So that is where the simultaneous equations and their techniques come in. So for elimination method, we want to get rid of one of the variables here. So either we must get rid of A or we must get rid of B. When we get rid of one of the variables, okay, then we only have a single variable and a single equation which we can solve and then substitute back into one of the earlier equations. Now let's see how we can actually apply this technique to this question over here. So the first step is let's rewrite the questions here. So I have 4a plus 3b equals to 44, and the second equation is 3a plus 3b equals to 39. Now let's number these equations. So I'll call this equation 1 and I'll call this equation 2. Now for the elimination method, it is straightforward. Okay, the moment you see that the coefficient of any of the variables for both the equations is the same. Okay, so the coefficient is the number in front of the variable. So in this case, if I look at A, I have 3 and 4, they are different. But if I look at B, I have 3 and 3. Okay, both are positive 3 and positive 3, which means that as long as I can now subtract both of these equations from each other, then the B variable will disappear. Alright, so what I'm trying to say is, if I take plus 3b and I subtract another positive 3b, the answer would be 0. Correct? So the b disappears. Okay? So you can put as 0 or 0b, but whatever the case, the b term disappears. Okay? So this is equivalent to 0. Now, so that is actually what I'm going to do now. Alright? And as I mentioned earlier, it is easy and straightforward the moment you see that the coefficients for the variable in both equations is the same. Okay, so what I'm going to do now is I'm going to say that I'm going to subtract, I'm going to take equation 1, subtract equation 2. Okay, so when I take equation 1, subtract equation 2, what do I get? So 4a minus 3a, I get a. Okay, 3b minus plus 3b minus plus 3b, I get 0. Okay, so I don't need to write that. Equals to 44 minus 39, I'll get 5. So that is your answer for A. Okay, so A equals to 5 is your answer. Okay, or the first part of the answer. Now we need to find the other unknown, which is B. Okay, so to find the other unknown B, I can take this A, which I've already solved, and I can put it into either equation 1 or equation 2. Either one. Okay, either one equation is fine and I'll still get the same answer. Okay, so let's put it into equation 1. Okay, so if I put it into equation 1, what do I get? I'll get 4a, which is 5, plus 3b is equals to 44. So I get 20 plus 3b equals to 44. 3b is 44 minus 20 is 24. So b is equals to 8. Okay, so I'm just going to show you that if I substitute it into equation 2, I get the same answer. So if I substitute a equals 5 into equation 2, I get 3 into 5 plus 3b equals to 39. Okay, 15 plus 3b equals to 39. So 3b is equals to 39 minus 15. Okay, so I will get 24, and b will be equals to 8. Okay, so as you can see, substituting the first solution into either equation would give you the same answer. So the final solution for this will be that will be written as a equals to 5 and b is equals to 8. Okay, so that's the final answer for this simultaneous equations question. Thank you for watching, and I hope that this video has given you a good starting point on how to solve such questions using the elimination method. Alright, so look forward to learning more techniques in the other videos in our .r YouTube channel. Thank you. Bye.